Now let me go through this third method. Third method is the most tedious way, but it provides some flexibility. For example, well, in this case, we have 7 covariates, right? Well, you just want to apply list-wise deletion for 5 of them, and for the other 2, you don't care. What are you going to do? Well, this method gives you this, option here. But in this case, again, I use list-wise deletion. So first of all, I supply the function, condition, right? So in this data frame, this variable happy is not equal to missing, and age is not equal to missing, and female is not equal to missing. And I go through all 7 covariates. Well, once any case satisfy this condition, right? That means that's list-wise deletion. List-wise deletion, because then I guarantee that the cases that satisfy all these conditions here, 7 conditions here, not going to have any missing for any of the covariates. And what I'm going to do, I'm going to use this which, okay, to pick the case number, okay, hidden in the memory. Now, so it's from 1, 2, 3, 4, going till 50. Okay, going till 50. And through various data management, we could have some ID, residual information from our original data file. Okay, that's not the ID I'm talking about here. I'm talking about the real case order, okay, after any data management and selection. So it's going to retain those authentic case ID, and then use this number to choose those cases. Okay, and that's the reason why we need to have a comma here. And we need to have a comma here because it is used to choose the case number. Okay, so we can apply this function and see what happens. So it picks this case or ID numbers for these cases, right? Let me apply the full function here by choosing this case ID for from missed DTA file, right? Then we can check into this new data frame. Well, again, it does not have any missing here, but people say, well, is this the same as the first and second data frames that we chose? Well, it's probably pretty time consuming to compare. We can compare first couple, that's 2, 3, right? 6. That's the case ID from the original data file, not the authentic case number for this data frame. So let's remember 2, 3, 6, 1, 1, 49, 35, 31. So let's remember roughly the first 3 cases, and let's go back to see if we have those. Yes, I think so. They're exactly the same. And again, I think so. They're exactly the same. Okay? So we can simply check some simple number. Let's say year number, 2000, 2004, and 2008. Right? And here too. We can also use this dimension function to check the dimension. Again, 33 rows and 7 columns. Kind of partly confirming that the data frame 1, 2, 3 are exactly the same using different selection methods. Well, people say, well, what if I don't want to apply list-wise deletion? I don't care about female, I don't care about education, but for all other, variables, I don't want them to have any missing. But for female and education, allow them to have any missing here. You simply take out these 2, conditions. Or sometimes you say, well, we should apply the logic relationship, let's say, or, right? It's simply, for example, happy missing or age missing. That's not called listwise deletion, right? Basically, it's going to delete cases. Excuse me, it's going to retain cases. No? So let's say, is instead of using and, apprehend, we can use or. When we use or, basically, let's focus on first two variables, happy or age. That is, either happy not equal to missing or age is not equal to missing. What's going to be retained? Well, it's either, happy has any value or age has any value. Basically, it's going to retain cases that at least, has one now missing value, okay, for either happy or age. What's going to be dropped? Okay, well, what's going to be dropped are the cases that have both missings for both covariates. So there are different scenarios and the situation can become very complicated. But this is to what? Well, first of all, this is kind of tedious, but this provides a lot of flexibility for retaining cases and dropping cases with different kinds of missing patterns.